Hello, math humans. We're going to do 2.2b today. We're going to be finding more derivatives, so learning more rules for derivatives. We're going to do derivatives of trig functions, we're going to find rates of change, and then we're going to talk about average velocity. So the rule that we want to get today is, let's say I have a function that is f of x plus or minus g of x. I can just split that up, and sometimes the derivatives are easier if you split the terms up, so then I could, in theory, take the derivative of each term separately, and then there would be g of x. So this would just be f prime of x plus or minus g prime of x. Okay? So now let's just start right in with some examples. So for your first example, I want to find the derivative of x cubed minus 4x plus 5. And again, this is really pretty simple. So remember that derivatives go down in power. So this is 3x squared minus 4. The derivative of a constant is 0. All done. Really, really very simple. So much easier than doing the limit definition of a derivative. The second example is going to say g of x is equal to a negative x to the fourth over 2 plus 3x cubed minus 2x. I'm just going to, and I want to find the derivative, so g prime of x is equal to what? So as I do that, I'm going to rewrite this. So this is a negative 1/2 x to the fourth. Here's my 3x cubed and the 2x. So g prime of x, which would be, here's the negative 1/2. The 4 goes out front, x to the third, 3 times 3x squared minus 2. Because if this is x to the first power, x minus 1, 1 minus 1 is 0, x to the 0 is 1. And now I just have to simplify this math. So this is a negative 2x to the third, 9x squared minus 2. And then I put my g prime of x out front, and there is my concise little statement. So that's pretty polite. So now we need to start getting some of our trig rules. So these are derivatives of the sine of x and the cosine of x. So the derivative of the sine of x is the cosine of x, and the derivative of the cosine of x is a negative sine x. So one of the things that's very, very important when you take your AP Calc exam is that you are responsible to learn the formulas. And I have given you that formula sheet, and so how I recommend learning formulas, so you have to memorize your formulas. It just is one of those things that you have to do. You can make flashcards and then review them on a daily basis. As we go, we are adding more and more things that you need to know. I tend to memorize things by writing it over and over, and that's just how I memorize. I would probably kind of use a combination of both, but you do have to memorize all of your formulas. While we are remote, then that is a little bit less important, but that is a task that we're going to have to manage when we sit for the AP exam. All right, for a third example, the derivative of 2 sine x, okay, remember a constant technically means that it can go out front, and then I just manage that. The derivative of sine is cosine, so this is just 2 cosine x. So dx is equal to 2 cosine x. The next example, example number 4, I'm going to have y is equal to x plus the cosine of x, and I want to find f prime of x, okay? Well, when I do that math, when I take the derivative, f prime of x is going to be 1 because this is x to the first, and then if I subtract 1, I get x to the 0, and that's just 1. The derivative of cosine is a negative sine x. Pretty simple. We like being able to have all of the rules because if I have to do the limit definition of a derivative, it just means that I have to work a lot harder. Okay? So we need to talk about, just to make sure that you have this stuck in your brain, derivatives. So remember that a derivative is the slope of a tangent line to the curve, and we find the slope of the tangent to represent the slope of the curve, or f, at a given point. And since slope or derivative is equal to slope, the derivative also gives us a rate of change. Okay? So we talk about all of these different applications for derivatives. So what I want to talk about now is I want to talk about a position function. So a position function in calculus is s of t. Okay, so this is going to be a position function. So this is going to give the position, think physics, of an object as a function of time. Function of time. Which means that's why we have this notation s of t. S is the position with respect to time. So in calculus, the velocity is going to be the derivative of position, which means that I'm going to do delta s over delta t, the change in s over the change in time. So that's going to give me velocity. Okay? So if I start with position, and I take the derivative of position, and a derivative is slope, or a rate of change, and the rate of change is going to be the y's, delta y, over delta x, and that's going to give me velocity. Okay? And then if I take the derivative of velocity, so if I use this notation, I could take the second derivative. So I could take the derivative of the derivative, which is going to be the change in velocity over the change in time, and this would be v prime of t. So the derivative of velocity is acceleration. Okay? So I'm going to just kind of write this again because this is a really critical thing to know. Position is s of t. Velocity is going to be s prime of t, and there is my velocity function, and then acceleration is going to equal s double prime of t, or it's going to equal the derivative of the velocity function, and that is acceleration. Okay? All right. So another thing that you will see as you're trying to manage these problems is the words that call average velocity. Well, average velocity, average of anything, is a difference divided by how many things there are. So this is just delta s divided by delta t, and so I could do the position function at A minus the position function at B over A minus B. So this is just the slope, but the average velocity, so let's say I have a function, and I'm going from A to B, and this point here is S of A, and this point here is S of B. The average velocity from here to here is just the slope from A to B. So that's actually kind of cool. Average velocity means it's going to be over a period of time, or delta t. This information right here is delta t. And then instantaneous, A-N-T-A-N-E, whoo, that's a long word. Instantaneous velocity is going to be velocity at a specific point, And so I'll move my paper up so you can see. So if you'll think about that, that's just the velocity, v of t, evaluated at a specific point, right? And so that's what instantaneous velocity is. All right, for your next example, we have a little word problem. So example 5, so bear with me as I scribble it all out. We have a billiard ball, love to play pool because it's all about physics, is dropped from a height. Maybe these guys aren't playing pool because they're dropping the ball from 100 feet in the air. Its height, s, at time t is equal to s of t is a negative 16t squared plus 100. You'll recognize that equation from physics. And it says find the average velocity over the time interval 1 to 2 seconds. So we want to know what the change in position of the ball is going to be over this period of time. So my average velocity, and this brings up a good point, in calculus when you are doing work, not only do you have to identify your answers, but you also have to identify your work. Okay, and this is going to be how I identify. So I'm finding the average velocity over the time interval 1 to 2 is going to be s of 2 minus s of 1 over 2 minus 1. The reason that we do it like this is kind of shorthand notation to show the reader that you understand what you're doing. And then I could just substitute these values into my function, and I'm going to get 36 minus 84 over 2 minus 1, and this is going to equal a negative 48 feet per second. And I want to talk about the units. So I'm doing a change in position over a change in time. The cool thing about rate is you always know what the units are because the problem itself tells you a change in position is going to be measured in feet, and then a change in time. In this particular problem, the relevant time unit is seconds, so then I know that I have feet per second. And so you never have to worry what the units are because the problem tells you exactly how to find the units. So then I would write that my average velocity from 1 to 2 seconds is going to be a negative 48 feet per second. And what that means with the negative means that it is just slowing down. Okay, or have a negative velocity. All right, the next example, example number 6, is another problem, word problem, so you have a little bit of writing to do. At time is equal to 0, a diver jumps from a platform, diving board, writing and reading at the same time is always kind of entertaining, that is 32 feet above the water. The position of the diver is s of t. S of t is equal to a negative 16t squared plus 16t plus 32. Yay, physics. We have two tasks. A is when does the diver hit the water? Okay, and then the second task is what is the diver's velocity at impact? Okay, all right, so we have two tasks. So my position function, s of t, is a negative 16t squared plus 16t plus 32, and s of t represents the position of the diver as a function of time. So if I want to know when the diver hits the water, that means his position above the water is 0. It means he's hitting the water. There's a bunch of different ways that you can solve this problem. So I would recommend I could do it graphically, so I could graph this in my function, do a zoomed fit, and he's going to hit the water. So this is time 0. He jumped up and he comes down and he splats and hits the water. If you do this in your grapher, you're going to find that time is equal to a -1 and 2, because this would be over here technically. But I can also do this by factoring. We love our favorite F word. If I take out a -16, I would get t minus t squared minus t minus 2 is equal to 0. And then the 16 goes away because I divide both sides by a -16. I get t minus 2, and I get t plus 1 is equal to 0, so time is a -1 and 2. Well, I'm not going to be concerned about that, so I know that the diver is going to hit the water at a -2 seconds. So he's gone up, he's come back down, he hits the water. So if I answer the question, sorry, you're going to have to reference, so the time to hit the water is 2 seconds, okay? The B part says, what's the diver's velocity? So remember that our position function was a -16t squared plus 16t plus 32. So then my velocity is going to be the derivative of position. So a -16 times 2 is a -32t plus 16. And then it says, what's the velocity at impact? So I need to find the velocity at time is equal to 2. So it's going to be a -32 times 2 plus 16. And when I do that math, I get a -48 feet per second. And remember, if you don't remember how to get the units, I'm taking the derivative of position. So it's going to be delta S over delta T, which is time per feet. That's really crappy grammar, but we get the general idea. So then the velocity at impact is a -48 feet per second. And then we would have answered both questions. Alrighty, that is it for today, my dears. I will see you soon.